when doing trig, you have to know this. I'm not putting this on top of the quiz. We're not doing a cheat sheet. You've got to understand the sides of your triangle when we're talking about trig, and also what sides go with what trig function. Now, a couple of things to try and help in case sometimes you get confused with these things. Here's how I always look at it when I'm trying to figure out my sides. The hypotenuse is always the easy one. Besides the fact that it's the longest side, it's always going to be in the same place. It's always going to be opposite from my right angle, because the longest side will always be opposite from the biggest angle, and that's always how it works. The bigger the angle, the longer the side it goes with. Now, might my angle move? Yeah, but in general, wherever I see my angle, it also should be easy to see where opposite is, because it's, well, opposite from where the angle's at, and then adjacent's the one that's left over. Because sometimes people say, ooh, this is all going to get confusing. That doesn't have to be bad either. If you can get these three down, those are my three basic ones, sine, cosine, and tangent. If you get those down, they're opposites. Notice you're just flipping the fraction over. Okay? Sine and cosecant are opposites. They're inverses. Cosine and secant. Tangent and cotangent. Now, tangent and cotangent, that's the easiest one to remember because they sound the same. The other ones, though, it's going to take a little bit more getting used to, but we're going to have a chance to do that as we're playing with these. So, right off the bat, we're going to see if we remember something else here. Because as you look at numbers 1, 2, and 3, you're like, okay, find the values for the 6 trig functions. Okay, so I got my angle. So here's my angle. And you're like, what do we have working here? Okay, so sines first. So I look up here because cobwebs are still getting out a little bit on this. Opposite over hypotenuse. Well, if I know this is my angle, I know this is my hypotenuse. It's opposite from my right angle. I know this is opposite because it's opposite from my base angle here. So sine's just opposite over hypotenuse. Okay, opposite over hypotenuse. That's not bad. But then I get to cosine. And I'm like, okay, cosine's adjacent over hypotenuse. Well, uh-oh. There's no number there. And this is my adjacent. How in the heck am I going to figure that number out? There's a way.
5 squares minus 13 squared.
Okay. We're going to head Pythagorean Theorem style here. Okay, so we're going to blend a couple of things together. So if I have a missing side, we're going to use the Pythagorean Theorem. But I like the way that Ben mentioned that already. If you had the hypotenuse, you could do 13 squared minus 5 squared. Now, some of you are creatures of habit, and you're like, no, oh, good Lord, Hardy, do not change this equation on me. You can just do 5 squared plus x squared, or whatever squared you want this to be, equals 13 squared. That would work too. So if I'm going to crank this out, kind of do this up here, if I have the hypotenuse, I can just take care of this in a little bit faster of a form here. And again, let the calculator do some help for you if you need it. Okay? Don't think you've got to do all this on your own. So, what we'll do is I'll show you some ways to kind of quicken things up in the calculator, but I don't want you to do everything there because that's when we tend to get ourselves into trouble here. All right, so we'll swing this guy over. So here, because sometimes as quickly as some of you go, you're going to want to make sure, and again, square root's just second to x squared. I think we probably talked about that before. So my x value here is 12, and now I have what I need in order to be able to find all my trig functions. Cosine is opposite over hypotenuse. tangent is opposite over adjacent. Okay, and it's just getting used to, okay, cosecant is hypotenuse over opposite, because again, it's just the inverse of my sine. If I wanted to find secant, once I know cosine, I just flip it over. If I want cotangent, I take tangent and I flip it over. So if you can get the original three, the other three shouldn't be anything too bad at all. So if we do that again in number 2, you're like, oh great, he gave us a missing side again. This time the hypotenuse is AWOL. We have the opposite. We have the adjacent, because again, opposite's always the second easiest thing to find. It's opposite of my angle that's marked. This time though, I've got the two legs. I don't have the hypotenuse this time. Yep, square them and add them. And then square root it. Yep, and so if I work through all this and take my square root, x is going to end up being 20. So my hypotenuse is 20. Not only when I'm forming these, let me bring this back down so we can see it. Okay, opposite over hypotenuse. If it reduces, you need to reduce it. So like here, I can divide each of those by 4. So I end up with 4/5. But again, if at the start here, you need to look up at the chart and just kind of go like, okay, cosine's adjacent and hypotenuse. That's 12 over 20. And I can reduce that. Okay? You'll get used to it. If you start doing these regularly, okay, opposite over adjacent, opposite over adjacent, it's 4 over 3. Once I get those base 3 down, the rest should be a piece of cake. Sine and cosecant. Cosine would be secant, so I can just flip that over. And cotangent would just be my tangent flipped. So again, it's not that it's complex, it's just how long is it going to take for sine, cosine, and tangent to kind of work their way into your brain. You've all probably heard with the SOHCAHTOA thing before. That can work sometimes. But sometimes it can just be kind of getting into a groove with it and kind of playing with them more. So, huh? SOHCAHTOA will always work when it comes to getting your base 3. For some people, though, just remembering that, they're trying to remember, like, now how do you spell that? And they kind of start looking at it, and it's like, so that can kind of get at people. Well, if you remember it, let me know, and I will get it put into one of these, and we'll talk about it, because I'm always looking for ways to help things kind of click a little better. So I'm going to go past number 3 for right now, because it kind of repeats things. Because you know how it gets in here. Things don't always come straightforward with this stuff. So we're going to throw a little twist in here. All right, in a right triangle, angle A and angle B are acute. Okay, that makes sense. If the tangent of A is 7/12, what's the cosine? Okay. I would say a picture is in order here. So it says A and B are acute, so A and B aren't going to be my right angle. So I'll make C my right angle. These are interchangeable. If you put B up here and A over here, that's okay. That's no big deal. But here's where we start figuring this out. Like, okay. Tangent. What two sides do I use for tangent? Opposite and adjacent. So my 7 represents my opposite. My 12 represents my adjacent. So they're not going to draw me a picture. I got to do this myself. So if it's the tangent of A, here's my angle I'm working with. The opposite side is 7. The adjacent side is 12. So you're like, okay, so that just gave me basically what my triangle looks like. But the question is, what's the cosine of A?
13.9.
So what sides do I need for the cosine?
Opposite over adjacent.
Adjacent over hypotenuse, okay?
So,
So you're like, okay, well I have adjacent. Okay, adjacent's 12. And then I've got to figure out what my hypotenuse is still.
You gotta just do applying whatever theorem it is.
Right, you've got to keep applying the Pythagorean theorem here. So in this case, 7 squared plus, 12 squared equals x squared. And they won't always come out nice. In this case, it definitely doesn't. So 144 and 49. Whoa, whoa. I don't know what was up there. Calculator had a mind of its own. So here, basically, I'm just taking the square root of 193. And you're going to get some decimals sometimes, and that's okay. So yeah, 13.9 is fine. Okay. And we're just looking for forms. If something goes in nice and it can reduce, that's great. But if it doesn't, not a bad deal. Let's see, let's play with one more of these. So let's draw a picture here again. This will still be C. I just like keep putting my things in the same spots here. Okay, we just got done here saying cosine is adjacent over hypotenuse. So my 1 is my adjacent, my 2 is my hypotenuse. So here's my angle. The hypotenuse is always in the same place. It's always the longest side, opposite from my right angle. And adjacent's the one that's connected to my angle. So I'm trying to figure out what this is. Now again, if you want to keep going with this format, you can. You would just have 1 squared plus x squared equals 2 squared because I have the hypotenuse this time. Otherwise, what I can do is I can take my hypotenuse squared minus my side squared. Now if you want, and this is going to seem strange to some of you, but this is actually the way it shows up in books most often. In this case, with the square root of 3, you can actually leave it that way. You can actually say, okay, this is the square root of 3. And you could have done that in the last one too with the square root of 193, but some of you said 13.9 already, so I'm like, okay, we can work with that. And so my tangent of A is opposite square root of 3 over adjacent. One. If you have the hypotenuse as one of your two sides, you can subtract. If you just have the two legs, then you add. Okay?
I'm just gonna die.
And so that works out for me that way. And again, I won't yell or scream either way, but like I said, most of the time the radicals are going to be the way answers are written. They'd be that way on the ACT or any other standardized test that you'd see. So I'm probably going to put most of my answers, just leave them as radicals instead of trying to do something fancy. Okay? So that's what happens when they kind of start twisting things on you a little. And I'm going to keep twisting here. Figure out the side? Nope. Nope, my main thing is the actual, what we're up to here. So I am not worried about that. All right, I'll get to that. All right, so, yeah.
How come we left the second one as a radical but the first one not? Never mind.
I should hit pause, but I'm not going to. Okay, so then we get into always the fun part. Yes, we get into story problems. Something to make note of. I will keep barking this. Your calculator has to be in degree mode. If it has gotten moved to radians somehow, it needs to get out of there for now. So what you would do if you don't know how to do that or to check, the mode button up here right next to second. Yeah, see mine? Bad right now. Degree. We need it to be in degree. So mode, if it's not in degree, make sure it is. And every time you pick up one of these, check it to make sure it is. So otherwise things get ugly.
What will it do?
It will mess up your answer. Not by a ton, because radian measures are all involved in like pi and degree measures, where degree, there's a slight rounding difference that you do when you're dealing with radian mode versus degree mode. So make sure we got degree mode. So let's see what we got here. We got John. John is standing. Okay. I am an artist. There's John. Okay.
Why are you here?
John is standing 150 meters from a water tower and sights the top at an angle of elevation of 36 degrees. How tall is the tower? Okay.
I got this, man.
So, 150 meters from the tower, 36 degrees looking up at this tower.
You're good at drawing triangles.
How tall is the tower?
Well, you're going to be using sides,
So, when I do this, here's my angle I'm working with. Which two sides
opposite, adjacent.
am I working with? I'm working with opposite and adjacent. So once I see what sides I have to work with, that tells me what trig function I'm using. I'm using tangent because I have opposite and adjacent, because I'm going to use one of the three basics. So the tangent of 36 degrees is going to equal opposite over adjacent. And I've now got to solve this equation for x.
Yeah.
So, what's my one step to get x by itself?
Multiply by 150.
Multiply by 150.
Oh, I remember doing
Got it.
So, all I have to do, now that my calculator's in the correct form, is say, okay, 150, and you can put the times in there, but you don't have to, times the tangent of 36.
Wait.
And we'll go to the nearest whole meter, which means this building is 109 meters tall. And this is, when you have like engineering and things like that going on, this is what they're doing to figure all of this out.
Thug life.
No, nothing to do with thuggery, just engineering. So, are there ways this can get twisted up a little bit? Sure. Okay, for instance here, Jessica is 150 feet from the base of a building. We're like, okay, this is starting to look like the last one.
But she's up top.
She measures the angle. No, she's not on top. 150 feet from the base, so she's still down here. She measures the angle from her eye to the top of the building to be 84 degrees. If her eye level is 5 feet above the ground, how tall is the building? Okay, so here comes my ultra awesome drawing again. Yeah, we have to be able to tell that it's Jessica. Okay.
There's some locks.
Okay. So, Jessica is 150 feet from this building, but now we're kind of looking at it.
Elevation 84 degrees. Wow.
So here, she's looking. We've got this building over here still. Kind of looks like a
84
bird with a beak,
minus-
okay?
Wait. Oh,
But what we have to keep in mind is we're going to end up finding the height of this building. But we've got to keep in mind that she's got this 5 feet that she's working with.
This girl is tall.
Right. So
Just kidding.
when I go to do this, okay, 150 feet away, I've got the same two sides again. I've got the opposite, and I've got the adjacent. So what I would do here is I can do this a couple of ways. I can either say, okay,
Yeah, he's tall. This building's tall.
I got the tangent of 84 degrees. And I can do one of two things. I can either take her 5 feet into consideration right now,
Nah, dude.
or I can wait a little bit. Now, normally I wait on this, just so I don't do something screwball. So if I can figure out the height of the building, we'll be able to figure this out. So, got my tangent. I'm going to multiply, again, by the 150. So, let's see here.
1,427.
Oh,
I'm guessing.
you're just guessing. Okay. So 1,427.
Which makes it 1,432.
Okay, because, right, I'll notice if she's 5 feet above the ground, and that's my x,
Yeah.
I've got to add her extra 5 feet to that.
Yeah, it is. That's right.
Okay, so don't let this crazy stuff start, getting at you. Okay. Now, one more minor thing to take on here, and then I'm going to save special triangles for tomorrow.
Very good. I know special triangle. Yeah, the
All right.
45.
Notice
30.
up in the right corner here, right under the name, it says use second function
Second.
to find the angle.
Yeah.
In other words, okay, here I don't need to find my other side.
You fucking angle.
I need to find this indicated angle. So what sides do I have?
Adjacent over hypotenuse.
Okay, I have hypotenuse and adjacent, so which trig function are we using? Cosine.
Cosine, right.
So, the cosine of something equals adjacent over hypotenuse.
So you put that in inverse.
So here's how this works. Right. When I go to my calculator, we're going to do second cosine, which brings that little -1 up. And then I'm just going to type in my fraction. 23 divided by 47.
Close. 60.
And then we're going to take that to the nearest degree, which in this case would be 61 degrees.
And 29.
Right, so if I wanted to know the other angle, it'd be pretty easy at this point. Right, I'd just subtract the 90 and the 61 from it. So when we're doing these, as long as I can get, let's see, let's do 2 and then I'll jump around just a little bit. Oh, that's boring. We got the same ones again. Adjacent
Exactly.
and hypotenuse.
Shoot. 22 now.
So again, I would do second cosine and adjacent over hypotenuse.
22.
Okay, yep. If you're getting something different than the angle measures we're getting right now, again, double check, make sure you're not in radian mode, 1. And number 2, make sure you're hitting second before you're hitting your trig function. So let's say we jump down to 4. What sides we got? Okay. I got opposite, I've got adjacent, so we're looking at tangent. Opposite over adjacent. And what's that going to get for me?
Which one are we on?
4.
Number.
Number 37.
That's it.
Okay. So that's how these. No, these, I could reduce the fraction, but whether I have it as 15 over 20 or 3 over 4, when I put it into the calculator, I'll get the same answer out. So that's a good question. So here's where we're going to kind of stop for right now. So here's how this is going to work. Since I don't have that on this one, the special triangles, keep hold of that. That's going to be the first thing we see tomorrow. Now, for right now, that is what we are playing with. You'll notice in a look ahead to tomorrow, on the special triangles sheet, we're going to do a pretty nice little load of the odds together, and then your job's going to be to play with the evens on that sheet tomorrow. But for now, just work with these. So tomorrow when we come in, we'll talk about these. We'll talk about whether we stick with homework checks or whether we're going to daily and how that could impact some things.
If we do daily, does that mean you're going to collect them every day?
Yes.
I like that.
I think you should like combine.
Yeah?
Or you should check to see if we did it